And today's topic, or a little snippet of me, is that I lived in Sudan as I was a kid. I actually studied at the American school in Khartoum, and my parents were working at the embassy there. And also what happened there is that I got my very first computer, this thing right there. Anybody know that piece? Yes, ZX Spectrum with a 16 kilobyte thingamajig in the back of it to give it 4 times as much memory. Where's my mouse? There we go. Now, of course, today you can do that in the browser without needing any extra memory with the original soundtrack of games and stuff like that. Awesome, isn't it? Totally worth it. And that brings me to the fact that even though we can emulate older computers in our browsers, we're still hungry for more power. Ta-da! Web workers. Anybody who actually, of course we've all heard of web workers, but who actually use web workers in any project? Nice. Actually I expected a bit less, but of course I knew about you. Is this thing supposed to fiddle on my ear? Yes. We've all seen this one too, right? The famous error message when your script is not responsive and some browser gets upset by the fact that it's taking too long. Or actually in a particular case, I don't know if you know about that edge case, in I think browsers up until IE8, this message was shown when more than 5 million synchronous calls were made. So it had nothing to do with the fact how fast or slow it was. If you had a magically super fast script, it would show, but with 5 million executions, it would show this error instantly, basically. So it wasn't very reliable. But anyway, that is because JavaScript is single-threaded. And heavy processing and data loading and all sorts of things can seriously degrade the user experience because the processor is busy with doing something else and not user interaction. Also, if you want to do stuff like video manipulation or image editing live, then it's difficult while the processor or the single thread is taken up by changing the colors in your image or something like that. So to rescue web workers, they're working a new thread in the OS, not just the browser. They live in a restricted area. They communicate via the post message API, which is the same thing that's used for what is it called, cross-origin messaging between different windows. And this will be more important later, but I thought I would mention it now as well, that data is actually copied between the worker and the real thread, and it's not shared. Not shared literally. They pass it back and forth, or they duplicate data. And you have no access to DOM. That's an important one. So everything that you need to do with the DOM happens in a single thread. Of course, it would be hell if you had different workers doing different things to your DOM, and you're trying to synchronize all that to be looking good. So it's a good thing. I found this very nice little diagram on actually Microsoft's website, which gives you a quick overview of what you can do in a web page and what you can do in a web worker. What you, of course, immediately notice is this hill over here related to everything DOM is gone. But also you should notice that the global object is not window anymore. It's the worker's global, which you can refer to as self or this. And what else is here? Yes. The navigator, which you have in the worker, is actually only a subset of the navigator that you have in the regular web page. I haven't run into any problems because of that, but it's good to know in case you're missing something that you're used to. You have access to timeouts and set intervals, and of course Ajax, so you can get more things. Now you might say without, no, this first. So I thought at this point I'll show you why you would wanna use workers. What kind of performance gain do you get? So I picked up this somebody else's what is it called, ray? Yes, exactly, a ray tracer, and looped it to keep running tests. See how long it takes it to draw this image. Now the very first one is of course without workers. The second line, it runs each test I think 5 times. The second line is showing you the second one is 2 cores, 3 threads, 4 threads, yada yada. Now this computer, which I'm running it on, only has 2 threads. It's a mid-2010 MacBook Pro. It has 2 real cores, but it has 4 virtual ones. And I think it's quite clear from this graph, actually, that the massive gain you get in speed sort of goes away after the first 2 cores. There's a bit of change, of course, from what my computer is doing in the background, so it varies up and down, but you can really see that after the second core or the second thread has been spawned, you don't really get much more speed gain. In fact, if we draw this graph much longer, it would start going up. Now, the reason it's pretty flat is because these threads are basically doing the same thing. It's splitting up the calculation to this ray tracing into more and more workers. Now, there's a bit of cost to spawn a new worker, but if they were doing completely different tasks, then obviously the fact that they are sharing those threads would show much more. I didn't do another experiment with this. I probably should have, because it would have been interesting to show you that if you have multiple threads, one thread, the more and more threads you add, one thread will start losing more and more power, of course, logically. So you shouldn't do too many. Sorry, wrong window. So it is totally worth it to do as many threads or workers as you have cores. Support is awesome. There's a big gap that happened in Android, as you may notice. After 2.1, they pulled it out. I Googled it a bit. I found some forum threads, but I didn't quite understand if it says anything to anybody. The reason is that it required some kind of locking that Android didn't have in its V8. But that's why they stopped it. But now in 4.4 latest Android, it's back. So basically, everything supports it, which is great. So there's no reason not to use them. Yes, also a side note, although not regarding support, but more of usability. On iOS, since iOS always prioritizes the user interaction, well, mostly, but very much so, so JavaScript is completely halted when you're scrolling natively or doing something with the interface. And therefore, the threads will stop as well. Even though you have a background thread doing something, it will be stopped as well while this is or while the interaction is happening. It's just something you need to know, so you can't rely on it updating something for you while your user is interacting. Now we're going to do some code. And here I have to focus not to miss my cue for something. So these will be the steps we'll take roughly. It's just so you have an idea: setting up, detecting, setting up, and communicating, debugging. So detecting with anything that has a proper API is easy as pie. We check for window.worker. Is it there? We're happy. Setting up, if you're using an external file, it's this easy. Of course, you have to obey the same origin policies. So same host, same protocol, same thing. Yeah. This is my favorite, though. You can do inline. You can spawn inline workers by using whatever way you want. But this is my favorite, actually using a script tag which is unreadable to the browser, by changing the type on it, so the browser just avoids executing anything in there. And then you grab that content, you create a blob, you create a blob URL, and you make a worker out of that. And I say, what is the blob URL thing? Well, I have to read this because I still don't have it in my head. It's a simple URL string referencing stored data. Now you can store images in there, you can store text, basically. This is pretty much text to JavaScript. It will be unique every time you create one, and it will be gone as soon as you unload the page, so you don't really need to worry about it unless you're creating them by the dozen, but hopefully you won't be. This below here is exactly what a blob looks like. You get this back from the create object URL, and the browser itself will store that thing imaging somewhere, and in Chrome you can actually view your blobs by opening this. I thought you could turn this into a link, but it didn't quite work. So I have none yet because we haven't gotten to that stage. Well, you would see them here, but you wouldn't see much info. You would see what kind of file it is, what kind of blob it is, and its weird address. Also worth noticing, since you have this same origin policy for workers, is that it will include whatever address your site has into the blob's address, so that you don't have any problems. But you can't take this blob and use it in another site, obviously, because it will not work. But it's also connected, so it doesn't matter. Blah, blah. Sorry. Sidetracked there. Yes. Additional scripts. obviously you might need some in case you're dependent on some library or framework. This is the way to get them into your worker. You just import them. Another important thing, but I think I mentioned this earlier. So the scope of the worker is the global scope in there. You can refer to it by this and self. Whereas outside you have window and, or you can just don't use anything. You can do the same in the worker, but you will have the worker's global scope in this and self. If you want to communicate with your worker, it happens, as I earlier mentioned, via the post message API, and this is how it happens. Yes, using this method, which is actually quite, I think, straightforward. Is there anybody who can't really read this? Because I think it should be quite easy. I wouldn't go through it line by line unless somebody really requires it. You require it, or what? Did I make up?
What is the reference to the
Yes, yes, yes. I think I have that in the notes, but yes. On the main script, event target will, when you catch an event from any number of workers, event target will contain a reference to the worker, so you can actually send a message back or know which worker it is. Soon we will open, do some kind of live coding, and then there we'll look at what's inside there. Yeah, the event target changes, so you should notice that on the worker side, you don't actually get a reference to the main script or anything there. You actually get your dedicated worker global scope. So it's not the same story. You can't just take one script from here and put it there. It will obviously not work because of things like that. But with clever modifications, it will. You can send basically primitives and JSON structures with this current setup. I think JSON structures are now supported in all browsers, because I know previously it was primitives only, but I think by now, don't know. I think by now it's everywhere. Now there is a high performance cost in sending a lot of data this way. It is because every time you send any kind of data, it will be serialized and then deserialized, either way. So it is kind of expensive, especially if you want to put like megabytes of data through this. So it's not something you should do. It's expensive. And also important to notice is that every data you send is basically copied. It's not referencing the same data. It's not, not sharing in any way. It is duplicated. But yes, hence it's called structured cloning. Oh. Now that we have a worker that's pretty much ready to start chatting and doing work, we started by sending it the first message. And hopefully, we have one right here. Now it's not doing anything because it hasn't been started. This simple script basically contains not much more than event listeners on whatever worker we create later on, for both errors and on messaging. For messages, and a very simple output that will blurt out whatever we send it in a readable format. But I'm narrowing down the data to only these keys because these are interesting to what we're going to talk about. Obviously, we don't want everything else that is part of the event API. So I have an external worker, but that basically does the same as this worker right here. It will just tell me that it's listening or it's ready. Hopefully, if all goes well and the demo gods are with me today, ta-da! Word from external worker. There we go. That's simple. I told you it's easy. Now let's go to an inline worker. And our inline worker is talking to us too. Awesome. That's going better than I expected. Yes, we started it. Now we need to do some error handling, obviously, because, well, nobody's perfect. So then, no. And we... Are we happy? No? Did I do a typo? Yeah, there we go. It just took a bit of time. So as I said, did I say that? No, I didn't. How about I say that first? So inside the error event, we get some useful things back, like the file name, the line number, and the meaningful message description. And Yes, that is what we have here. Isn't it beautiful? Of course, we're using a blob, which is not very handy, that we can't read the real file name, but that is what we are using as the file name right now. Yes, the rest is self-explanatory. We have an undefined function, and that is correct. Next up, terminating. Because we don't want worker to exist after it has done its job. Well, you might want to reuse them, but in case you don't, you should get rid of them. So there's two ways to do it. You can do it from inside the worker with just self-close, or you can do it from the main script by using terminate. And although it is not something exciting, but I thought I'll make a demo of it anyway, because it's fun. So let's see. Are we happy with that? Wait. You're not supposed to be here. And of course I should enable this for it to work. There we go. We get data. Now the interesting part obviously in demonstrating that I terminate the worker is the fact that I terminate it. Now when I send it a bye, inside it will call a self-close and send me a sad face. Now you may notice here that I do one more message to the worker, but we get nothing back from that because it is unfortunately dead. Now if we do the same thing on the main script side, since it is instantaneous, we have nothing back because I killed it before it could send any messages to me, but that demonstrates that terminate worked. So worker is gone. Let's get back to this. Debugging. Don't get scared. There is no console log, but it's okay. We have other ways to debug the script. For example, in Chrome, very handy dandy. I should have shown this, but anyway. You have a separate tab under sources for workers. This thing about shared workers can be inspected in Task Manager. I'm not quite sure I get that because I looked and the only thing you can see is another task in the Task Manager. It's not actually, and there's no any way to inspect the worker itself from what I could see. But your shared worker, which I'll talk about later, will show up in your scripts. So you can debug it if you need to. So Chrome is very handy for debugging. It does a good job at giving you the tools. IE 11 and 10, surprisingly, are very good at that too. In IE 11, you can just the same way as in Chrome, click on the drop-down for scripts, and you'll see your worker there, and you can inspect and put debuggers and see what's up. So that's very handy. The thing that came as a shock to me is this one. I don't know if anybody who else worked with web workers actually found a way to debug them in Firefox. I could not, neither in Firebug or in their native DevTools. So they support them, they work, but you can't in any way debug them. Interesting. Now what I mentioned earlier about the problem with, transferring large chunks of data. There is a solution. So while sending them via post message by default will copy and cause a whole bunch of data to be in your browser on both the worker and the other side, you can use transferable objects, which uses something called array buffer. Now please don't ask me what it is. I'm sure you could tell, but I can't really. I looked at it a bit. I thought I should include something about it in my presentation. Then I said, nah, this is too much time. So I skipped it. But what this magic does is it allows you to send data over, basically switch the context for that data that you're sending. So it will disappear from your worker or from your main script and appear on the other side. And it will be gone from the other. So you have to be careful. You have no longer access to it once you do this kind of transferable object transfer. The great thing about it is super duper fast. You can send large chunks of data in absolutely no time. See, I sent 32 megabytes. Wasn't that awesome? Yes.
We use it sending from the backend to the frontend.
Yeah.
And we do it without serializing data from C# to JavaScript.
Oh, array buffers.
Yeah.
Yeah.
Typed stuff. It's processing. You don't do any serializing at all.
Yeah.
But we only support it in like data.
Yeah, and then there's a catch, of course. Our favorite catch, IE. I unfortunately does not support transferable objects yet, even in 11. I checked, so too bad.
Is there a polyfill for that, maybe?
I don't know. That I did not look for, to be honest. No, that would be great, but I mean, it has to fall back to the old method, which means it will be slow. But I guess you could polyfill it by using post messages if you really need IE for your cool thing. So I mentioned earlier that there's something called shared workers. What we talked about so far, mainly, was dedicated workers, which have a one-to-one relationship between the worker and the client or the main script. With shared workers, you can actually have multiple pages on the same origin, share a worker, which is of course great in concept, except there's a lot of red on the screen. Now hopefully that will change, because share workers allow us to build really, really great applications, since we can have one worker in the background, not yet, one worker in the background doing polling or processing, and then share the data with multiple pages as it's done with it. Now this is done via something called ports. So there are shared workers have a concept called ports, which allow the worker to reference different pages that it is giving data to, where it's being called, and communicate with them. This is what it looks like in use. It's a bit scary at first, but basically the only thing that happens, should I step into the screen? What you should notice, first of all, is that the shared worker has a start, and also on the client side, or on the worker side, you have an onConnect event, which you didn't have earlier. And that is because you want to keep track of every new page that connects to this worker. And then you can talk to them separately by grabbing the event source, which is where the worker has been called from, spawned from, and then you can talk to it separately. Of course, you shouldn't be doing it like this. You should keep track of each individual, but I don't want to make the code any more complicated. This way you can create clever apps, as I said earlier, that share one process that does the heavy lifting and then share its data with multiple views of that process. So for example, I think a stockbroker app would completely rule with this. You would have one script continuously talking to the backend, getting fresh data, and then you would have all the different views in front of them updating automatically in separate pages. Yes? Real world. Now, something that Björn mentioned earlier. This is what I really wanted to do as a pet project to support my presentation. Unfortunately, it was done before me. The CPU estimator. The accuracy of such a thing greatly depends on how well it can sense the speed difference from the number of threads it creates. Now, because of modern technologies like hyperthreading and turbo boost and other things like that, it is not really predictable, since it splits up tasks to threads that aren't on real cores. And therefore, it says 4. I only have 2. And next time I run it, it will say 3, and the other time it will say 2. So, you know, there's a plus minus 2, roughly. Hey, there we go. I actually guessed that very well. Scary. But it is relatively accurate in a sensibly off, basically. So you could use it as a... Exactly, it's a good enough measurement. I mean, you're not going to ruin your device by spawning this many more. This is still okay.
Det den gör är väl att uppskatta vilket som är det optimala antalet workers under rådande omständigheter för att...
Sorry, I'm a bit too...
What it does is estimate how many workers you should run for the optimal speed under current conditions. So that's usually what you want to know anyway. You don't really care about how many cores
are really there. Yeah.
You care about what amount of workers would give you optimal speed. So
yeah, but I mean, also depends on the task it does.
Yeah.
So
that's
yeah.
That's why I mean you realize that maybe 2 was better now because the garbage collector was already running on one of the cores that you.
Yeah. Exactly, but that's what I was wanting to do, and here it is. You could use this in a real solution to make sure that you're not killing the processor, but still taking enough load off the main thread that is meant for the user. Now, I found these cases to be the most sensible for workers. Obviously, it's not a magic tool for everything, but in these cases, I think it makes a lot of sense. I definitely found text editing to be a good one, because I know some editors suffer from, oops, did I not open it? Some editors suffer from performance issues. And for example, ACE uses workers to push, what is it? To push autocomplete and syntax highlighting to a worker, which is, I think, a great idea. I wish the one I am currently working with did this, because it's very sluggish. But this would be a great idea. Of course, they have their own abstraction on the workers, but I mean, it's something that we should totally do, because the processing power is there, and basically you don't want the main thread to be stalling as you're typing or editing the text. It should be focusing on you and highlighting when it has time or in the background. Big data is an absolute. Huh? How did I do that? Big data is an absolute winner, and big data is something very hyped these days. So processing while doing other things. As you can see, I could not select the text while it was working. I couldn't do anything with the page. But with the web worker, of course, it's doing the massive sort, and the page is still responsive, as you would expect from any modern application. So there, it took a bit longer, but that varies a lot. Sometimes it's the same. But it left the UI completely responsive while doing this 50K sorting. So big win, use it. Image processing is, of course, another must-do. You want your your editor to be focusing on you while you're doing things with it, and not on calculating stuff. Now, this is just a comeback from the original introduction to myself, Sudan. This is my classmates from Sudan, and this here weirdo is yours truly. Back in, what was it, 90? Yes. But basically, as you would expect, this should be doing what you want it to do, or the lever should be reacting instantly, and the change should be happening in background, as it does. Image editing and video editing is an absolute goal or absolute must-do for perfect use case for web workers. And, of course, another obvious choice, games. You definitely do want as much responsiveness as possible, humanly possible, out of a game, so that it turns left when you push the button in that millisecond. And therefore you can, yes, there's music to it, therefore you can push the AI, obviously, to it, and all the 3D stuff that most games have to do should all be done. Now, I really suck at these games, but as you can see, it reacts very quickly to what I do, and I could push the wrong button to not do anything. Oh, there we go. Very responsive, but yeah, I don't know how to play this game. Yes. Back to this. Did I leave anything out? Yes, spreadsheets. I didn't actually bother to find one because it's such an obvious choice. But if you have a gazillion calculations on a spreadsheet, and when you change a field, you don't want it to be sitting for a while. You want that to be calculating in the background. So that's another perfect win with a web worker. And that brings us to, pretty close to the end, if you're doing any computation with JavaScript, you should definitely opt to use web workers if they're available. The result is both faster and a better experience for the end user. And this was said by John Resig, who actually built jQuery, among other things, back in 2009. I don't even know that jQuery existed in 2009, nor web workers really, but yeah, he said this. Now, of course, anything, as everything, should be taken with a bit of pinch of salt. So, for example, if the initialization time and the communication time is longer than the actual processing time, you shouldn't really use web workers. Or if the memory cost is too high and it's damaging the performance of your main thread, you shouldn't use web workers. And of course, you have to also consider one important factor is that since you're pushing work to different threads, you have to make sure that the information that is synchronized when it comes back. So you have to sort out synchronization of the dependency of the information. That's a terrible sentence, but does it make sense? No? And yes, once you've done that, please use web workers because they'll make the web awesomer. And now why is this? Where am I? Oh, I lost my mouse. That's it. Presentation over. At this address, you will find all the links and sources, and including this presentation online.